Hi guys, welcome to the last segment of the show. So guys, we've really been doing some great stuff here with our circle geometry. We looked at some circles and quadrilaterals and exactly how do they link to one another and what are the relationships inside a quadrilateral, provided it has a circle in it or the circle is around it. What are these theorems that we're trying to look at, and exactly what would then be the converse of it? So if I do know that this is the case, what conclusion can I draw? If I don't know, what conclusion can I draw? All of those things, right? So right now, we're actually going to try and see how do I then link this to questions, right? I'm gonna try and show you a few questions where you get asked to solve certain things based on these theorems that we've done thus far. So let's just have a look at it. But before that, I have some exciting things that I want you to first think about, some deductions I want you to think about based on the previous theorems that we did with our previous lessons or for circle geometry. Let's just try and look at it, right? So here, when we are applying these theorems, I want you to think about what deductions can you then make from this diagram. And also you need to then give me reasons why you are claiming what you are claiming. Because remember, I told you, we do not do something because it looks like it or because we think it is it, without having proof for what we are talking about or having a foundation. That's why we start with these theorems and then apply them later on. So what deductions can we then draw from this, right? So if you look at what we are having in this particular diagram of mine, clearly you can see that if I add these two angles, I definitely will get 180 degrees, right? So the very first thing that I'm going to say is AB, or rather, let me not use that one. Let me do this. So we'll start by saying first, we know that angle B plus angle D is equals to 180 degrees. It's not that I'm saying it because it's a cyclic quad. No, I'm saying it because you can see that I can add these angles here and get 180 degrees, right? So meaning this is my 86 degrees plus definitely 94 degrees, which is then equals to 180 degrees. So I'm giving it as 180 based on that, right? But now, more interestingly so, what you can then see is I have a 90 degrees here, I have a 90 degrees. Yes, clearly when I add them, I'm going to get 180 degrees. But this is where I want to actually draw your attention. If I was to draw a line through here, what deduction can I then say? So if we are looking at that red line that I just threw there on the board, you need to think about what can I then say? And I know, I can see you guys that you know what I'm talking about, right? So that line is gonna then be called the diameter. One, why is it a diameter? Because remember the theorem that we did, we said a diameter subtends a 90-degree angle on the circumference, right? So on either side of this particular line that I just threw now, we will then say that what? Those angles are 90 degrees, therefore the line, in this instance, the line BD will then be my diameter. So line BD will pass through the center of the circle. So that's one of the things that you please need to be thinking about. That's one of the deductions that I'm going to draw from this. So let's see exactly what do I mean. So I will say BD is a diameter, right? I will just say or rather let me write it in full, diameter. And the reason why this is actually a diameter, why? Is because angle in semicircle. I will say SC, right? Why? Because you can see that this angle here is a 90 degrees and that angle is a 90 degrees. And normally you know that a diameter subtends a 90 degrees and a diameter subtends a 90 degrees. The other deduction I know that somebody might say there is ABCD is a cyclic quadrilateral. Really, that you can say is a deduction, but it's not really a deduction. Why? Because already the 4 points are on the circumference of the circle. So given that they are on the circumference of the circle, I can't then really say it's a cyclic quadrilateral. No, they are on the circumference. So that means it is a cyclic quadrilateral. So it's not really a deduction. Right? A deduction will be something that if you were to do this, then you will find this. But in this instance, ABCD, though, is definitely a cyclic quad. Why? Because the 4 points are concyclic. So that's what you need to think about there. Now let's look at more interesting questions to do. It says, in the following sketch, BC is parallel to DE, right? So I have BC is parallel to DE. So this line here and that line are parallel to one another. And if they are parallel to one another, it definitely makes this angle to be equal to that angle, raising alternate angles, right? And then we can try and talk about certain angles or certain things under there. And we are given that A is 130 degrees. And then they want us to find the size of C1 and F. So I want to come to the side. So let me use maybe a more colorful color here. So we agreed that this angle here is equals to that angle there, right? That's alternate angles. Given that this is 130 degrees, we know that this one here, this quadrilateral here, the 4 lines, they form a cyclic quadrilateral because the 4 points are on the circumference of the circle, making this to be 50 degrees. So already, I'm not answering questions as yet. I keep on saying to you, I'm only looking at what can I do on this diagram based on the statement. Right? If that is 50 degrees, this one is also 50 degrees. Why? Because they are alternate angles. And if that is 50, then this will be 130 degrees. You see? So that's what I have so far as the additions that I can make based on the fact that I know that this is those lines are parallel and also there's a cyclic quad and all of that. So firstly, angle C1, I will say that angle C1 is equals to 50 degrees, and my reason for this will be opposite angles of a cyclic quad. Right? Remember, I did say that with cyclic quad we normally write as Q to show CQ, I mean, to show the concept of a cyclic quadrilateral, right? And then the other thing that I will then do that they needed me to find was angle F, right? So with angle F, I will then say that this angle here is firstly equal to that and then link it to angle F. So I will first say C1 is equals to D1, and this is equals to 50 degrees, and the reason for this will be alternate angles. Remember, for you to say alternate angles, you must also state which lines are parallel. That's because BC is parallel to DE, right? I know that. And then from there, I will then simply say F is equals to 180 degrees minus 50 degrees, which will be because of opposite angles of a cyclic quad. Opposite angles of a cyclic quad, therefore angle F will be equals to 130 degrees. I don't need a reason for that, guys. It's just math. I'm just subtracting two angles. Also, in the following sketch, ABD, right? As you can see, ABD is given as 40 degrees and ADB is given as 35 degrees. We want to find with reasons the size of C1, right? So firstly, I will then, let me go to the next slide so that I have more space. So firstly, I will say in triangle ABD, right? In triangle ABD, I know that angle A will be equals to 180 degrees minus 40 degrees minus 35 degrees. And this will be because of sum of angles in a triangle, right? Sum of angles in a triangle will be equal to 180. So that's why I'm subtracting there. So 180 minus 40 will be 140 minus 35 will actually be 105. And that's my angle A. But that's not what they wanted me to find. They wanted me to find angle C1. So therefore, angle C1 will be equals to angle A, which is equals to 105 degrees. And my reason for this will be exterior angle of a cyclic quadrilateral. So I know that for a fact. So this angle is an exterior which is equal to the interior opposite there. So I know that for a fact. Some people might want to first find C2 and then use angles on a straight line. Really, it's one and the same thing. C2, you will say opposite or supplementary, find C1, and then you can be able to solve that. But that's a longer route because already there's an exterior angle that I know about there. Another question is in the following sketch, MTS is 50. I can see that. And I know that MT is equals to MS. So already with this diagram, I know that this angle here, this one here will also be 50 degrees, right? Reason being, this will be an isosceles triangle because already I'm told that these two are equal. So that's already 50 degrees as well. And if that is 50 degrees, this will also be 50 degrees because why? They are subtended by the same arc, right? They're subtended by the same arc. This angle there and that angle there. They're subtended by the same arc. And then determine with reasons the size of P. So already I will start by saying S. S is 50 degrees. My reason for this will be angles opposite equal sides. And since I know that, I will then say that P is equals to S, which is equals to 50 degrees, and this will be angles in same segment. Right, and then voila, I've done that particular part. So far we've looked at circle quad theorems where a converse angle is in the same segment, right? That's what we're talking about in terms of a cyclic quad. We also know that opposite angles of a cyclic quad and also its converse. The last one is exterior angles of a cyclic quad and its converse. And so far, that's our concept map. So guys, that's what we had for this lesson that we needed to look at. The relationship between a circle and a quadrilateral around that circle and what are the properties that I can talk about. But please remember, the fact that I say it's concyclic does not only make it to be that makes it a cyclic quad. No, cyclic quad is because of the properties that I just gave you now, the three theorems that I just showed you now in terms of the summary. Guys, remember, mathematics is food for the soul. I will see you guys next time. Bye for now.
Bye.